Okay, today we'll be talking about oxidation reduction, which is basically the transfer of electrons from one species to another. So let's start off with our sample problem. We have iodine, the ion, plus bromine yields bromide plus iodine. So our first step is to write the oxidation states or the charges above each of these species. So iodide as the atom, is the ion, has a charge of -1. Bromine is a diatomic element, that's why it has a 2 as a subscript. And since all atoms are neutral, it has a charge of 0. Same thing goes for iodine. So once your oxidation states are in place, our second step is to determine what is being oxidized and what is being reduced. So by definition, oxidation is the loss of electrons. And in numbers, this means that we'll have an oxidation state going from -1 to 0, these as examples, or 0 to 2. And this concept is a bit counterintuitive because you have the number actually going up, indicating a loss. And the reason why is because electrons are negatively charged, and they're written as with an E, the negative sign on top of it. And when you're gaining electrons, or in this case you're losing electrons, the number is actually going up. It's becoming more positive. So the less positive a substance is, the less it'll be negative. And so that's why you'll have the number going from a smaller to a bigger number. And reduction is exactly the opposite. It's the gain. And here you'll have, for example, 2 going to 0, just the same backwards numbers, 0 going to -1. And the more electrons you have, the more negative the number is. So now we can determine which of these species becomes oxidized and which is being reduced. So you look over and you see that the iodide ion is going to the iodine element, which is a -1 to 0. And this number is going up, therefore it's losing electrons. So this represents oxidation. And by process of elimination, or theory-wise, the 0 is going to -1, so the number is going down, electrons are being gained. This is reduction. Now that we have our oxidation and reduction labeled, we can create our half reaction. You split it into two sides. One side will be oxidation, one the reduction, and you just simply substitute half of the equation in each of the sides. Since the iodide is being oxidized, it is going from -1 to iodine, so a charge of 0. The first step in balancing this half reaction is to balance the number of atoms. And here we have 1 and 2, so we'll simply put a 2 on this side to balance and account for the number of atoms. And the next thing is to account for the charge. So again, this is a little confusing for students to understand where to put the electrons, whether on the left side or the right side. The easiest way to think of this is to balance in terms of numbers. So on the left side over here, you have a charge of -1. And since there are 2 of those atoms, or in this case 2 of those ions, you'll actually have a charge of -2. So total charge is -2 on this side. And on this side, you'll have a charge of 0. So what can we do to balance that? Well, here in this process, you'll be adding or subtracting electrons. And when you're adding an electron, you're actually subtracting, because an electron is a negative number, and if you add a negative number, your operation is subtraction. So we're going to be adding the electrons on this side. So we'll add 2 electrons to balance the charge of -2, and so on each side you have a charge of -2 here. Moving to the reduction side, we'll take the reduction part of the equation, which is the bromine going to bromide. And again, here we'll have to account for the number of atoms, so we'll put a 2 on the right side. And in this case, you'll be adding electrons on the left side, because you have a charge of -2 on the right. On the left, you'll want to also have a charge of -2. You'll be therefore adding, if you can't see that, I'll write it clearer, 2 electrons on this side. Your final step is to combine this equation. And so you'll take everything that's on the left side, so the left side of each of the equations, and on the right side you'll have everything that's on the right side of each of these equations. So now we're going to write this out in full terms. So you have 2 iodide ions plus 2 electrons from this side plus 1 bromine yields 1 iodine plus 2 electrons plus 2 bromide ions. Now that you have it all written out, you can see that there are 2 electrons in each side. Well, if there are equal numbers of things or electrons in each side of the equation, we can cancel them out. And if your electrons are canceled out, you know that you completed your oxidation reduction balancing properly. The final equation written out will simply, you'll simply be left with the final equation. So in your answer, you're going to be looking for the balanced equation. So you'll simply substitute the coefficients into your original equation. 2 for the iodide, and 2 for the bromide. And now your equation is balanced.